Sitting at the top of the periodic table, we have hydrogen, the most abundant element in the whole universe and among the most reactive. Therefore, it is mostly found bonded to other elements as we see in water. See, unlike fossil fuels, which when burnt pollutes our environment and produces carbon dioxide, which causes global warming. Hydrogen, on the other hand, which when burnt produces water, which does not have any adverse effects on our environment. In this video, I'm going to show you how you can make this gas at home. I'm going to perform some tests on this gas and show you some of the mistakes you shouldn't do. And we are going to burn some things with this gas we have produced. We are going to melt some metals. Well, basically, I'm going to show you how to produce this gas from water. To perform this experiment, you need an empty lighter bottle, a scissors, salt, super glue, empty bottles, USB cable, matchsticks, a computer power supply or a phone charger, nails or spools, whichever you prefer. Now try to replicate what you see in the video. That's all. I'll be explaining it at some point, which might prove to be a little bit difficult. But for now, try to replicate what you see in the video. The reason why I'm using the sand is to make it gas proof. See, we are going to be producing the gas in these containers, and then the gases are going to be very pressurized, so they have to be gas proof and also waterproof. And I'm using the sand so it can form a very strong bond with it. Yeah, so it can form a very strong bond with the plastic and make it gas proof so that the gases don't leak from the bottle. Now, the reason I'm putting this green material there is simply because you will be moving that lighter a lot, and the joints which you've made with the super glue are mostly rigid, which can break and cause the gas to leak out. So I've placed that material there so it won't make the joint move and also keep it stiff and will make it last longer.
Yes. What? Ah. Mm.
All that is left for us to do is now to put in our salt and the water. Now, you don't want the water rising too much to the point where it covers the tube connecting the first chamber to the second chamber. What you want to do is you want to fill it almost full, but don't let it cover the tubes, or else container when the water in the container start to react, it will push the water from container 1 into container 2, which you don't want that. And here what I'm doing is I'm simply attaching a cable to the electrodes. Now you attach two cables to the electrodes and then attach them to your power supply or your phone cable. Which in my case I'm using the power supply. So one of the cables must be attached to the red wire, whilst one is attached to the black wire of the power supply. The phone cable also has these connections in it, a red wire and a black wire, but sometimes it is a red wire and a white wire. Either way it is, you can connect any of the wires to any of the electrodes. It won't bother or hurt anything here. Now watch as I turn it on, you can see some bubbles forming on one of the electrodes. Yes, now that's the hydrogen being produced. So if you leave it here for a little while, you come back and you will see that the container with the bubbles forming in it will be very hot. Then that is where the hydrogen is being produced. Now the hydrogen will travel from the container where it is being produced to the other container. Now that's where it will be stored, then converted into the fuel for anything you want to use it for. The bottle has become very, very pressurized. Now there's a lot of hydrogen gas inside. We can begin our testing very soon. And the container where the hydrogen is being produced has become very, very hot as well. So the lighter will be used as our burner. Let's test the flames. So hydrogen mostly emits its light in the ultraviolet spectrum. Well, what that means is the flames are going to be invisible. You cannot see them. But that doesn't mean they are not hot. The flames of hydrogen can reach about 2000 degrees, roughly about 1800 degrees Celsius. So hydrogen flames are very, very hot, and when they burn in pure oxygen, they can reach about 2500 degrees Celsius. You can see the flames of hydrogen. That's what makes it sometimes a little dangerous. But it is very hot, so it is mostly used in welding, where you require high temperatures for melting the metals together. So I mistakenly caused an explosion because I adjusted the lighter to allow a higher flow rate, which caused the buildup of gases and introduction to flames, a sudden explosion. So don't adjust the lighter to allow higher flow rates, because this is hydrogen, it might explode. So I'm now about to test it on paper in the dark so you guys can see the flames very well. The flames look like a laser. The way they burn is like they are pressurized. Now I'm going to try to melt steel with it. Then after that, I'll try to burn the lime next to the steel wool. So that's it for this video. Now some tips to help you make your reactor work. Well, first of all, make sure you don't use too little glue, or you are going to get some leakages which you don't want for hydrogen. And also make sure to use harder plastic bottles that can withstand pressure, because they might break. If you learn something new, you can consider liking the video and sharing it. And also, thank you for watching. Very much appreciated. Thank you very much. Wow, I'll take my leave.